Welcome to another GCBASIC video demonstration. Not really. This is all about AVR ASM 2 trickery, and it's sharing with the community what I've learned over the last 3 months, and based upon what I knew previously, and how AVR ASM 2 Microchip have got trickery, so they can actually compile things. Let me show you what's going on. I've got attached here a C Nano board. It's a 2019 AVR DX, and we've added that to GCBASIC. And on the way, I determined there was some trickery going on, and I'm going to show you how that trickery impacts you and how you can get around it. Well, just so you know, GCBASIC supports not only these DXs, these new chips, but it also supports old chips like the old style AVRs and LGTs, which are basically Chinese clones. It does both. It does all three, and it does it from the same language. But there's a difference when you go to compile a DX file inside of the new toolchains, like MPLAB-X or MP Studio, which used to be called something different. It used to be called Atmel Studio. But there's trickery going on that you just need to have an understanding of. So let's recap what GCBASIC is. It's an open source compiler for PICs and AVRs. It supports these DXs. It also supports LGTs. It's going to support. I'm working on a new chipset from Nuvoton. It could do Z80. It can do 6502. These are the main ones. And how it works is there's a tool chain, and that tool chain, I'll draw a pen actually. Pen options. It takes your source code, which we'll have a look at shortly, and it pre-processes it. And it takes a set of libraries and what's called a DAT file. The DAT file describes the chip to the compiler. It's essentially all the parameters of a chip. It takes it through into what's called a code translator, and that code translator puts it into a common language, and that the source code could be assembler, it can be GCBASIC, but the code translator ensures it's all syntax correct. Goes into an assembler that's part of the toolchain, goes into a linker, and then it outputs a machine code specific hex file. On the way, it produces some reports and some text files and a CDF file, stuff you can have a way through to see what's happened. But it also always pushes out an assembly file. And that assembly file is really what GCBASIC has determined as an optimized set of assembly for that particular chip. Well, what you can do, you can use that assembly file inside of other tool chains, and you've always been able to do this right from the outset, 2007. And here's a modified diagram. If you notice the difference in this area here, there's something added in here. The linker's changed. Well, let's have a look what happens. Same source code. I'll bring my pen back up. Same source code, same libraries, through the preprocessor, comes through here. Whoops, there we go. And then it goes, you can take the assembly and you can push that into a toolchain. And the one I'm talking about today is AVR ASM 2. And you need a chip-specific input file called an INC file to make that work. And that's always been the case. And you can specify that in your ASM source and it will work. It will no longer work because of the trickery that's going on. And I'll explain that deeper. After you run AVR ASM 2 and you've got a valid compilation, you'll get a machine code. And then you can pass that to your program and away. Great. So let's have a look at some of that in action. I've got a very simple program here. This program here, I'll zoom in, is essentially flashing an LED. It says it's for a Mega 4809, pulse out on an LED port and wait 5 milliseconds. And it's doing that, we can see that on this oscilloscope. And if I program it in GCBASIC IDE, this is using the first option we saw. it's actually already programmed it. Hard to see. Let me just let me go into Zen mode and see if that helps. No, I'll zoom out. I'll bring in the oscilloscope. Let me see if I can do it like that quite quickly. I'm just going to program it out to the oscilloscope, and we'll see the oscilloscope is so fast. What a pain. Let me try it this way. We can see the oscilloscope there. I'm going to push this up here, which is a little icon that says make hex and flash. It's now compiling it, and we'll see a small flash on the oscilloscope where it actually programs it. So it's gone through the whole process. And if you don't believe me, I'm going to change that to a 10 millisecond delay just for this run. And we're going to see it do it. And it will just change the waveform. Now, well, the important thing is here, what we're saying is it's taken the source code, it's gone through the GCBASIC process and produced a machine-specific file, and it's programmed it. Takes milliseconds, okay. All right, let's go back to where I was. Okay, so we've got this program, and if we look at the assembly file that was produced, remember that we compiled this using all of the GCBASIC toolchain, so there was no external interaction. It says in here, here's a file, and here is the magic include file. The magic include file is .include M4809 def.include. And that would have worked if this was an old legacy chip. It would have worked if it was an LGT. But it doesn't work if you try to pass this into AVR ASM 2 without a load of command lines that you need to understand. And the issue is, how do you get that working? So I'll just show a little trick. Control C, I've taken a copy of that source file, and I'm going to use MPLAB IDE. Okay, everyone moans about this, but do you know what? It sort of works. And I'm going to add in, I'll do it quicker actually. I'm going to take a copy of this file location, copy file location, copy the path, and I'm going to add it into my program here, an existing item. I'm going to add it into there, select, and now I've added that source file into MPLAB, production, build the project. Down the bottom, it's already, it's built it already. It's quite quick today. There we go. It says it's done it. You can't quite work that out. I'll just make that a bit smaller for you. Come on. How do you resize? Oh, it hadn't finished in actual fact. That's why I couldn't move the screen. There we go. It's made a machine-specific hex file, and it's used the ASM source. But let me reassure you, it ignored part of my ASM. That is what the trickery that's going on. So where is that trickery? We got some warnings in here. That's not the trickery. Let me reassure you, that's not the trickery. It's in this line. It's in that line .include, because what it's done is inside of here, it's actually changed the command line, and it says here, I have changed that to this particular location. The include file has now been replaced by something called C-colon users admin microchip packs, microchip, DFP, some version number, AVR, and it carries on until it finds the actual file that was in the assembler. So they've got some trickery. They've had to fix something because they use these things called DFP packs. It's the same inside of Microchip Studio. So you can't use the old ASM. Now, if you tried to, therefore, if you wanted to compile this from the command line, you would have to pass it this specific location. Well, that's not good, and that's not what we do. Okay, so let me show you what the issue is. We'll dig deeper. Back to my PowerPoint. Getting AVR ASM 2 working when using these DFPs, DFP is that version number that we saw. Let's recap, go back, is the version here. This is the DFP pack, and there's lots of DFP packs. You can zoom in, look, DFP, and there's lots of DFP packs. Let me do. Here's a DFP manager, and this one says there's lots of DFPs, and these are device, family packs, and they get updated by Microchip, and the version number changes and its location changes. And if you use the MPLAB-X or Microchip Studio, it's all fine. But that doesn't work when you want to make things very easy for end users, because the location of the include file is dependent upon the DFP version installed. It could be in your program files. It could be in your user profile. You'd have to wade through to find an include file. And then when you change the chip, you'd have to go find it again. And then you'd have to pass it that parameter on the command line. Well, that doesn't work because that's not easy for end users. Because the ASM include file address location is ignored in the ASM source. The trickery is going on inside of those toolchains. So you can pass it as long as you know it, but you don't know it. Let me assure you, you won't find it easily. So what we've done, what I did over the last 3 months is I implemented my own trickery to make that easy to implement, so that we can actually pass the correct location of the DFP location of an inc file to the compiler. Let me show you. This is back to that same program, and I'm going to change the compiler to AVR ASM 2. I do that by pressing function key F4, and there's this drop-down menu. Other ways to get into this. I'm going to edit my preferences, and inside of here, I get shown this screen. Well, if I bring that up so you can see in detail, to change it to another type of assembler, I just select AVR ASM here, and now it's going to pass my assembler file, as in per the diagram I showed previously, out to AVR ASM 2. Trust me, this would work if I was using the old version, but now I'm using AVR ASM 2 as installed with MPLAB-X or MP Studio. I have an issue. So I'm going to press function key F6, which says make the hexadecimal file, and I will pull it up, and it says here, get it there so you can see it, cannot find the include file, which is I expected, because I have passed it this location as I would in the past. I passed it that. That was valid in the old days. It's no longer valid. So how do I change that? That's the challenge. How do I change it? We use a little trick that's always been in GCBASIC. I type in the chip name. I type in the full chip name, like as in the chip above, and I put DFP, and it will go and update. It will find the location for you of the correct DFP file where the include is located, and it will change our assembly. Don't believe me? Let's try it. First of all, that's popped up. Determining location, there's a little utility, and it's compiled it successfully. So something has changed in the ASM file, and the ASM file now has a full specification where that include file has been located. Trickery. Because this include file has carried out a full analysis of the installation of MPLAB-X, or it could be Microchip Studio, and found the correct include file. If you want to use AVR ASM 2 as your assembler, you don't need to, but I'm just ensuring you understand what's the trickery that we've implemented. How does it do that? There's a little utility. Okay, let me just pull it up, a little DOS window. There we go, DOS window. Currently, I've called it AVR DX, some horrible name. Don't worry about the XE name, okay? But what you can do, this is being called in the background of the compiler once you put that include line in. And actually, you can actually do this, like you can say, give me the include location of a particular chip. Oh, that sounds clever. Let's do that then. Include location mega 4809. It told me, look, it's in this folder. It's in a folder name with a version number. Hey, why don't we go there and have a look? Here it is. Here's the folder. Look. These are the two folders. So I've obviously got two DFP packs installed. And if I just rename that folder for you, and I rerun that application, it will return a different result because it's fallen back. It falls back to the latest version that's installed. So our utility gives you the latest version. If I put the folder name back as it was, it will return that back to 2.269. Hey, what else does this thing do? It will list for you all of the chips are installed in your installation. So look, and this goes on for days, okay? This will go on for quite a while. What else can you do? You can deal with the things in here as well. This utility is grander than I'm showing you at the moment. Because what we're doing here, we're changing the behavior of our toolchain so that it actually integrates with Microchip's Studio and MPLAB. And essentially, rather than having this extremely complicated command line that you would need, it's actually this is the command line it's actually executing inside of MPLAB. I've extracted it so we can see it here. It says here, look, compile up create me a hex file, use a map file, use an LSS, and produce E file, which is a EEPROM file. There's a temporary directory, and here is, oh look, this happens to be for some other program I'd imagine that I pulled out yesterday. This is using a DFP pack 2.22509. Ooh. Then it says find this file, and then it says, oh, you can also find it in this folder here. So something in MPLAB Atmel Studio, well, it's actually Microchip Studio now, uses 2.2 for this particular chip. So it's like insane the way they've done it. There is no way that you should be able to say, here's my include file, go do it. It does not do that anymore. This resolves. This will produce a valid hexadecimal file. So if you wanted to include some just use GCBASIC as a wrapper for assembly, just as a wrapper for assembly, because you can do that. Let me just take some assembly from in here. This is the source. Look. Let me have a look what we're doing here. Set the pin on. There you go. I'll take this assembly here, and I'm going to put that raw assembly inside of here, and I'll compile it. Okay. So you can actually type raw assembly into GCBASIC. Most people don't do that, but they can. Quite easy. I just created a hex file. You created a hex file. And you created a hex file because up here, that location is correct. So if I wanted to change that to a tiny 3217, ooh, 3217, I will change that to the same 3217. I don't think it has a port F, so it has a port A. So we're doing assembly here, okay? It's a bit quicker to do it in GCBASIC, I can tell you, but we'll just demonstrate it here. I'll compile that up by pressing function key F6. There's other methods of doing that. It's determined, missing include. Oh, it's a tiny, I got the typo in here, look. Tiny. At least it did give us a valid error message. It has taken that and compiled it. And here is our assembly. It's changed the location to 3.12260. It's got a def file, and everything else in here is actually set up for you, to be quite frank. This has set up all the frequency. It's set up all of the ports as digitals. It has, what else? It's set up all the vectoring for you, defined all your registers, and do you know what? It has not done a bad job. If you wanted to have no processing by GCBASIC, no processing, you could actually use ASM raw, you can put a block around it and say, I want a block of this stuff. I want a block of assembly, and close that block. This is raw assembly. It will get passed unprocessed by GCBASIC to AVR ASM 2. And it's doing the trickery that you get with MPLAB-X and Microchip Studio, because the trickery is going on in here quite correctly. Oh, it even determined this value copy on R21 for you, okay? Where is the assembly? Let's have a look. Oh, there's the assembly here, untouched by human hand. So it just passes it straight through. So what I wanted to show is the complexity of using MPLAB-X, or what it's doing. It's doing the trickery, it's playing with the command line, changing the include location. But we've got a little utility that you can call from within your source program to do the include file for you. It will automatically update that location depending on your latest include file, because you might have different DFPs. You don't need to install the whole of MPLAB to get DFPs, by the way. Okay, there's lots of tricks you can do in there yourself. I'll let you worry about that. This is automatically sorting this out. So if we go to this location here in my file structure, this is different. We've only got the one version installed. No, that's the way it is, because I've only installed this in January. But it shows you then how it's working, what it's actually doing, the magic that's going on. It's reading an IDEs file in, it's then processing that XML, it's then searching through that for you and giving you the latest files. Dead easy. GCBASIC is easy. So I wanted to show you some trickery that's going on. I think I've done that quite well. Enjoy.